Let's move on. Okay, so mungkin saat no day Marisol here. We won't take them today. Okay, so let's continue. Now we are in chapter 6 where we are discussing the generation of fields once the electromagnetic field and the electrostatic field are coupled together. Once we have a coupling, we see that we have effective EMFs that are generated everywhere. We said now regarding the possible EMFs that can be generated, we can provide an example which will look like this. For example, let's assume that we have a coordinate system x, y, z, and we have a loop of wires which has a height h and width w, or we can put other letters. Maybe a and b would be better because the oscillation frequency, it can be omega. So let's do this one a and b. Okay, that might look better. And at this stage, let's assume that we have a magnetic field. Wait a second, this is x, y, b. That's good. Let's assume we have a magnetic field which is equal to AY times B0 times sine omega t. And at this stage, let's assume that we want to find the EMF. In order to find this EMF, let's also assume that the normal component of this circuit, it is at an angle alpha. And this angle alpha, it is, so let's assume the angle with respect to the x-axis, we have this alpha angle. Now, sometimes it might be a little tricky how to incorporate this angle alpha when we try to determine the flux. The flux is always equal to the dot product times the area, okay? And we know that, let's assume for a moment, if the area, it is in the xz plane, if, let's say, square at xz plane, if this is the case, then the flux will be equal to B times area, right? Because they will be perfectly perpendicular. But the moment that the square it is at an angle of alpha with respect to the x-axis, then the flux from B times A, this would be BA times cosine alpha. So it's always good to draw some intuitive approaches on how to do these calculations. So this means that the flux immediately, this is going to be always equal to B times A times cosine alpha. Now for a moment, let's assume that alpha, it is the angle between the square, but what this square has, it has several loops of wires. So you have a single beam. You have wires which are at the outer borders of this square. Now for a moment, imagine if the angle alpha is equal to 90 degrees, then so let's say if alpha is equal to pi over 2, then the square, it will be found on the yz plane. And then the flux will be equal to 0 because cosine pi over 2 is 0, right? So, yes. But it looks like this is the flux. But now, in order to determine let's say the EMF, let's say we want to find what is the electromotive force which can be generated over this wire. At this stage, in order to find this one, we know that the EMF is going to be proportional to the delta flux over delta t. So if we find the delta flux over delta t, we will have the following. Flux will be B0 sine omega t, so just wrote this, times A cosine alpha as a function of time. Now, out of all of these terms, the only function which depends on time is this. Then this is going to be equal to the B0. A is the area, so actually this area we can write as AB, but this is the product of one side times the other side. So this is going to be equal to B0 times A cosine alpha d times omega, we can put omega right here, times cosine omega t, okay? So this is the rate of change of the magnetic flux as a function of time. But then, if this is proportional to this is also minus this, so I can write with a minus sign, minus omega B0 A cosine, no, this is wrong. This is alpha t or what? No, this is just cosine alpha. Times cosine alpha times cosine omega t. Okay, so this is what we observe in case this square it is sitting at some angle alpha with respect to the xz plane. Now we can make the problem slightly more complex, which would be the following. We can have a magnetic field which is a function of time, so this is B as a function of time, but at the same time we can assume that this square is rotating at an angle with a frequency omega. Well, let's consider this one. For a moment, we can call this one omega 1, and this we can call this omega 2. Maybe it's better if we do it that way. So let this be omega 2. So it's rotating at some frequency. If that one is rotating like that, then we are going to have, or how do you think this flux is going to change if this one is rotating with a frequency of omega 2? What is omega 2? It would be 3 radian per second, 4 radian per second, 3 sikaya. How will the flux change? Now, I'm calling this square, but let's call this the loop, which has no wires, it's rotating. Like this. We are just rotating around like this. If the square, let's say, rotates, then the flux is going to be equal to B times A, B times A times cosine alpha. Now, the change here, whenever this is going to rotate, we know what alpha is going to be, right? So the only change that we're going to do is that we'll say that alpha is equal to omega 2 times t. Okay? So alpha now is not a constant value, but it depends on time. So this will be b times a. Maybe it's best if we write the b on this. B is equal to b0 sine omega t times a, which is the area, okay, which is a constant value, times cosine omega 2t. Okay, so that's it. This is the flux now. If you want to find the EMF, we are going to find the rate of change of the flux as a function of time. And then, we're going to put a minus sign, that's the EMF, right? But let's find the rate of change of the flux as a function of time. We know how we take derivatives, right? So if we have the derivative of a times b, this is equal to derivative of a times b plus a times the derivative of b. We can pick up a few terms and put them away because they are constants. So this can be b0 times the area times the derivative of sine with respect to time. Derivative of sine with respect to time is going to be equal to omega sine omega t times cosine omega 2t. Okay, so this is we did this derivative parts просто дютане derivатine, просто парне derivatine дудис. So наибайно это derivate. А there тук е derivative мусим да даме минус. So this is going to be minus omega 2 sine omega t sine omega t sine omega 2t. Okay, so this is the rate of change of the flux as a function of time. Now, what remains, I believe this is the answer. We can search for possible relations, but let's notice this one. This is sine cosine, but I think we may have something wrong here. No, it's not wrong. Apparently the B0, it is sine, okay? So this is what we get. Of course, we can put a minus sign, this is going to be the EMF, okay? Only that we notice that the EMF that is going to be produced, it depends on two different factors. One is because of the rate of change of the magnetic field as a function of time. Second, the rate of change of the angle. So for a moment, let's assume, actually we can try to simplify this expression to some degree. Let's assume omega is equal to omega 2, okay? Let's assume that both oscillate at the same frequency, and this expression is going to be equal to B0 times A times omega equal to omega 2. We can factor out the omega out, and this would be sine omega t cosine omega t minus sine squared, am I right? Omega t. Yes? Actually, you can even factor out the sine omega t because it's the same term. But at this stage, we can also consider the following. What if the magnetic field here becomes a constant value? Choose a variable constant. What happens? If B becomes a constant, that means that the rate of change of sine omega t, wait a second, where is the derivative of this term? This is, wait a second for that window. I made a huge mistake. Aș vrea să when we calculated the rate of change of the magnetic field, the derivative of sine is equal to cosine. Okay? Sorry, I just made this one. This is going to be cosine omega t. Let's see if we have other mistakes. Apparently we don't. Okay? And this is going to be cosine omega t cosine. Oh, okay. So here we go. This is cosine omega t squared. Yes. If this is the case, what is cosine omega t squared minus sine squared? Sadekio?
Yeah.
Shumajni. I think there is a relationship. There are some relationships regarding the cosinus and the sinus equal to theta. Actually, cosinus to theta. Just cosinus to theta. There are some double angle, so double theta angle relationships. Personally, I don't memorize this. I cannot memorize this one, but I believe this cosine 2 theta. It's equal to 1 over 2 cosine squared theta minus 1. So I think there is something like this. And then, okay, so how can we do this? Well, this is cosine squared minus sine squared. This is cosine squared t. How can you simplify this one? I cannot think too much right now. Cosine squared minus sine squared is 1 minus cosine squared, right? So this becomes 2 cosine squared theta minus 1. 2 cosine squared theta minus 1. Okay, that's good. We can leave it like this. So, but I believe there is a relationship like this. What about this one? How is this related to cosine 2 theta? Maybe there is no relationship. We can leave it like that. But it's just because that I cannot. Că? Cosinus 2 theta și sa? Sinus control. But then they show that cosinus 2 theta. Okay, so then this can be written also as B0 times A times omega times cosine 2 omega t. Okay, so it looks like if we have a piece of paper which rotates and we have a red wire across the edges and rotating at some frequency, let's say 10 Hertz, and then the magnetic field intensity also it's oscillating with a frequency of 10 Hertz, that means that the electromotive force is going to oscillate with a frequency of 20 Hertz, so it's going to change much faster. So what we can do here is that we can draw it like this. And it looks like, but wait a second. Oh, okay. Let's try to understand this a little better. So the B is a function of time. Maybe it's good to draw this one. Not that it's very important at this stage, but it's important also for your general understanding of the culture of phasor, how the different angles, different quantities can be out of phase with respect to each other. The B, how can I write B here? When t is equal to 0, B is 0, because sinus of Zerotec, so this is pi over 2, this is another pi, sorry, this is another pi over 2, another pi over 2 here, this is 2 pi. Okay, and this is the B. And then, actually, let's notice the, okay, so if we come here, this is going to be the EMF. Let's do this one in a different color. The EMF at t equal to 0 is 1, so this starts from here, and at twice the time, a little later, this is going to become 0 right here. So then we get here. So we can notice that in red color, where we did the EMF, this is 2 pi phase change. Pra faza kanë shumë 2pi, sepse ka qenë maksimum, ka shpet minimum, ka shpet prap maksimum. Edhe këtu prap, këtu kemi një ndryshim faze prej 2pi, sepse në të njëjtën masi kohë ka arritur prap shpet minimum, pa ka plotësuar ciklin e vet. Nga ana tjetër, një është të përdorim terminologji, thjesht për të bërë ekvivalencën, për të bërë koncepte të tjera, këtë mund të perceptojmë sikur kjo është një lambda dhe kjo është një lambda. Ose ne dimë që një lambda është një wavelength e plot. So one full wavelength is this. This is one full wavelength. Another wavelength is this. Okay? Another wavelength is this. So nuk është dy tipe singularës, it's not it's like one full wavelength in red color, it is completed. When it comes to the other frequency, so this is becoming a bit crowded, but this is in black, we get 2 pi phase difference from this point to this point. Okay? Yeah. Okay, so it looks like the EMF which is going to produce is going to oscillate much faster. In fact, some of the students might find intuitive, might find an equivalent principle when, so it looks like the EMF is moving much faster, right? Because it's an effect of two different phases competing or adding up together. In a similar way, students, you might have seen something similar when we discuss the wave, electromagnetic wave. You might notice that we have two different velocities. One is a group velocity, and the other one is a phase velocity. And the phase velocity, it can be larger than the speed of light. So this is the phase velocity. It can be larger than the speed of light, but the group velocity with which the information is transferred is always smaller than the speed of light in vectors. But now, this phase velocity, it can get faster than light because of two contributing phase differences in the same direction. But you just heard about it right now at this stage. Whenever we see this one later on, you might remember that we mentioned it right now. Now, we want to solve another example. D'accord, nëse bëhet ishte i bio bie constant, then we will not have this term. So if v would be constant, because here we took the derivative of sine omega t, right? So this one would not be here, so this term would be missing. We would have only this minus sine square omega t. Okay? So it's going to be sine square omega t here. And the oscillatory pattern of this EMF would have the same frequency, a frequenza de discendente, por amplituda do të modifikojmë sinus katrori. Sinus katrori si ndryshon vetë, negativ si ndryshon sinus katrori, sinus. Okay, so it's good to draw this. So yeah. So in case the magnetic field would be a constant or just B0, the EMF would be equal to minus the rate of change of flux as a function of time, and this would be equal to, actually this is a minus sign, so with another minus would become plus, so this would be B0A times omega sine square omega t, sine square omega t. And so actually the oscillation frequency of this quantity, it is still going to be omega t, only that the amplitude will be modified. So it will start from 0, then it will be a maximum after exactly pi over 2, okay? But the curvature will be different. So x in x controlling. If you remember, just like you do bars by x, kjo këtu shkon. Kjo është nish me nish, kjo është y bars by x. Y bars by x control është kjo. Anyway, it's just the way how. So this is sine omega t. I don't know how to draw this one. Maybe something like this. It's going to be different. The përfundojnë të pikat njëtër, por kur kontrolët e këtë pozitive. But so here we can write this is pi over 2. No, sorry, this is pi over 2. Yes, this is pi, and this is 2 pi as a numerical value. And this graph, we're not plotting this graph as time, but as a function of omega times time. Okay. Or we can do it anyway, so we can also plot it as a function of time, but then we'll have to divide some values along the x-axis. Is there anything not clear, or do we have any questions? Okay. A couple of comments in the class. Okay, if you have no. In fact, for sot not building, we can stop here.